Hey class, this is Gigi going over practice infinite limit question number 8. So we are looking at the function f of x is equal to x squared minus 7x plus 12 divided by x minus a. Instead of writing it that way, I'm going to go ahead and factor out the numerator. 2x minus 3, x minus 4, all divided by x minus a, because I will need that to answer these questions. In part A, the question is asking when or what is the value of a that will have the limit as x goes to a from the right being a finite number. Okay, so when you are approaching a from the right, a is just a little bit bigger. X is just a little bit bigger than a. Minus a, that's going to be a positive small number, right? Now, when you have a quantity divided by a small number, that is going to be positive infinity or a negative infinity. So what we will need to do is we will need to think to answer part A is to eliminate the negative small or the positive small on the denominator if we want to have an answer as a finite number. So basically what A could be is that A could be 3 or A could be 4, because your function can be, if A was 3, right? If A was 3, then you would have your function would be, when a is 3, your function would be f of x equals x minus 3, x minus 4 over x minus 3. And then you could go ahead and divide that out. So then the limit as x goes to a from the right of what's left, x minus 4, is a minus 4, which is a finite number. Okay, and then if x is 4, then your f of x is going to be x minus 3, x minus 4 over x minus 4. Then you can divide out x minus 4. So then what you will have is limit as x goes to a from the right of x minus 3, and that is going to equal to a minus 3, and that is a finite number. So that is our thought process for part A. We wanted to get rid of that negative positive small on the denominator. Okay, so part B, we want the limit as x go to a to be a positive infinity. Okay, so how does that happen? So limit as x goes to a from the right, meaning now on the denominator, you will have a positive small, and on the numerator, you would have x minus 3 times x minus 4. Now, what number can a be, right? What number can a be? So if the denominator is positive, then you would want your numerator. So we would want the numerator to be positive for your limit to be a positive infinity, right? because then you would have, this would be then a positive number divided by a positive small, which would give you a positive infinity. So we want the numerator to be positive. Okay, so how do we know when the numerator is positive? Well, the numerator is 0 when x is 3 or when x is 4. So those are our cutoff points. And we want to know when that product is positive. So let's check. When x is, say, to the left of 3, let's pick 1. You will have negative times a negative, right? That give you a positive. When x is, say, 3.5, then the first factor is positive, but the second factor is negative. So then the product is negative. And then when x is, say, 5, both of them are positive. So then the product is positive. So the answer to part B is A can be in the interval negative infinity to 3 union 4 to infinity. Whereas the answer for part C, we want to know when what A can be, so that the limit as x goes to A is going to be a negative number. Well, that means when is the numerator a negative number? The numerator a negative number when x is in between 3 and 4. Okay, so I'm going to go ahead and do an example of what that meant. So let's pick a number that is, let's pick A to be, say, 2. Okay, so at A equal to 2, then our function f of x is x minus 3, x minus 4 over x minus 2. Okay, and we want to do what? We want to consider limit as x goes to A from the right, that means approaching 2 from the right, of x minus 3, x minus 4, x minus 2. So when x is approaching 2, the numerator will be negative 1 multiplied by a negative 2, all divided by, remember, x is approaching 2 from the right, so it's a little bit bigger than 2. Minus 2 is going to be a positive small. So then this will be positive 2 divided by positive small, which would be positive infinity, as in part B was saying. Okay, so this is an example of part B. Okay, now, what's an example of part C? Well, let's take, for example, 3.5. Okay, so an example of part C would be when A is 3.5. Okay, then your f of x is going to be x minus 3, x minus 4 over x minus 3.5. And we are trying to take the limit as x goes to A from the right, so 3.5 from the right. And we're looking at this here, x minus 3, x minus 4, all divided by x minus 3.5. Now the numerator is going to be a positive number, right? Positive, actually, I know what that is. That's positive 0.5 times the second factor is negative 0.5 divided by, since x is approaching 3.5 from the right, I would have positive small. So negative divided by a positive, on the numerator I have negative 0.25 divided by a tiny number that is positive, I will have negative infinity. And that is what the question had meant to ask in part B and in part C. What can A be? Okay, what can A be? A be. So that the function has a limit of positive infinity when x is approaching a from the right. Well, we know if x is approaching a from the right, the denominator will be positive small. It's a positive number. So the numerator will be a finite number when you do a substitution, whatever a is, right? So then in order to get positive infinity, we will need the numerator to be positive as well. And the numerator is positive when x are belonging to this interval and that interval. And then the denominator is negative when x is in between 3 and 4. And so then the limit there would be negative infinity. So then the limit as x goes to a from the right of f of x here is going to be negative infinity.